Hello everyone, my name is Aaron Standard, and today we're going to be talking about modern NuGet, how to use centralized package management and source mapping. I consider these to be best practices for working with NuGet packages across any reasonably large solution. We've been using kind of a manual version of centralized package management inside our projects for several years now, really since .NET Core came out. But they've made this a lot easier, starting with some improvements that were introduced right around the time .NET 7 was released. So we're going to go ahead and show you a little bit about that. That's centralized package management. We're also going to talk about an important security feature that NuGet has introduced into the NuGet.config standard called package source mapping. And this is a way to kind of help enforce some supply chain security around your software. And then we're going to take some existing .NET projects and show you how to go from not using any of these tools to actually successfully incorporating them into your solution. So that's what we're going to try to cover today. And let's start by taking a look at centralized package management. So centralized package management was first made available in the .NET 6.0.3 SDK and also in all versions of .NET 7. So you need to be running on at least this version of the .NET SDK in order to take advantage of this. And what centralized package management introduces is a new Directory.Packages.props file. This is going to specify all of the different versions of all the various packages that you might use across your entire solution. Now, not every single project needs to use every single package specified in here. This is using a new format just to specify for any projects that do use this version of, let's say, Akka.net or this version of Newtonsoft.json or whatever. It's going to specify this is the version that all projects that do need to reference this are going to use. So all gets synchronized inside a single file here. And every single project is going to still have its own package references, but they're not going to specify an explicit version number anymore. The version number is going to be derived from what's in this Directory.Packages.props file. And this is automatically supported in Visual Studio and Writer. So if you ever add a new NuGet dependency to one of your projects that uses this format, that dependency will be added. Its version number will be recorded in the Directory.Packages.props file. And then we'll go ahead and just reference whatever version is in there inside our solution. This will make a lot more sense when you actually see the project file itself. And I've tested this myself. This whole system works great with Dependabot, which is a really useful way of keeping your dependencies up to date if you use GitHub. So Dependabot support is already built into how this whole structure works. And the benefit of doing this is that you're going to spend a lot less time dealing with issues like NuGet package downgrade warnings or dealing with DLL hell or daemon dependencies. By kind of synchronizing everything together into one location, all the projects in your solution all get upgraded at the same time. Package source mapping is a little different. This was introduced a little bit earlier in the .NET 6 lifecycle, and this is specified in NuGet.config rather than part of your actual solution file. And this is a software supply chain security feature that's really designed to help restrict which packages can come from which sources. Now, if you only use public packages that are available on NuGet, this feature is probably not going to add a lot of value for you. But if your company distributes, let's say, internal NuGet packages, or maybe you go ahead and get third-party packages from a supplier like SDK bin, for instance, what this is designed to do is help prevent package hijacking and impersonation, where what someone could do is that in the event I learn that Contoso has this contoso.utility package, I could go ahead and publish an unlisted package on NuGet.org, and that package dependency on NuGet.org will usually take precedence over your internal, let's say, Azure DevOps artifact, where you normally get that from. Therefore, I could essentially infiltrate your build environment without you knowing it if you didn't have this type of security feature enabled. So this is designed to kind of help make your private packages only come from sources that you trust, is the whole idea behind this. So it's kind of meant to help make sure that these packages come from this source, this package comes from that source. And it only takes about 2 minutes to implement. So you should absolutely spend those 2 minutes doing it if you're actually building production grade software that relies on private NuGet packages that aren't coming from NuGet.org. So without any further ado, we're actually going to step into a little code sample where I'm going to take one of Petabridge's open source projects and upgrade it to use both of these features. All right, so while we're here, I wanted to go ahead and take a look at the official Microsoft documentation on these features, and we'll include links to both of these inside the notes on this video. But basically, enabling central package management starts with need to create a new Directory.Packages.props file. And we need to specify this inside the props file that we want to manage package versions centrally. That kind of enables the feature for the solution. And then our item group right here is going to include a new package version element. This is different than the package reference that you see show up inside your CS projects today. The package version is going to specify the name of the NuGet package and the version we want to use. From that point onward, all of the individual projects that are going to reference this package are going to just include a package reference like they normally would, but without the version number. Instead, the version number will be calculated from what's stored inside this Directory.Packages.props file. And typically, you're going to want to put this file either in your solution, or if you're like me and you use a source folder, you're going to want to stick it inside of there. That way, all of the projects that are downstream from that file inside your solution folder, they're going to all reference this file automatically. So I'll go ahead and show you an example of that in just a moment. You can also override this file if you needed to, where if for some reason you had a project in your solution that needed to use a different version of the software than what was specified in Directory.Build.props, you could in fact override that via this version override attribute inside your CS project file. So you can override it if you want to, although in my opinion, you probably shouldn't need to do that. Package source mapping, on the other hand, this all goes inside NuGet.config. So if you don't have one, you're going to need to create a file like that. And what we're going to do is we're going to specify our package sources. So by default, I'm going to include, the NuGet v3 API endpoint here and any custom sources I might have after that. And then from there, we're going to go ahead and specify which packages should resolve to which sources. So by default here, I'm going to say, okay, all packages, unless otherwise specified, are going to pull from NuGet.org. That's the key for this particular source here. Otherwise, any packages that fit this pattern, such as contoso.star or NuGet.common, those are all going to be pulled from this custom package source I'm creating here. So this is going to essentially specify which packages can come from which of these two sources. Whereas right now, it's a little bit unclear where package sources might come from. And that's what creates the vulnerability from an open source supply chain standpoint. Someone could go ahead and publish a contoso.whatever package on NuGet, and that could actually get installed instead of the one that's inside your private package feed. Adding package source mapping prevents this type of vulnerability from affecting your solutions. So we're going to introduce that into our project as well. So for the project that I've selected to upgrade, we're going to go ahead and use this .NET New template that Petabridge maintains. This is our petabridge.app.web project. It's an ASP.NET 6.0 file. And we're going to transform this to use Directory.Packages and also to use package source mapping as well. So I'm going to go ahead and switch over to Sublime Text and then eventually JetBrains Writer, and we're going to perform this upgrade. One thing you will notice is I have a bunch of open Dependabot pull requests right here. I'm going to leave them open for the time being, and then after I have pushed and merged in my changes to use centralized package management, we're going to rebase all of these and see that the ones that are currently passing should still pass. That's because Dependabot has the ability to automatically work with these new central package management formats. So let's go ahead and take a look at this in practice. Okay, so I've got the petabridge.app.web solution up and running inside Sublime Text here. And what this file is, Directory.Build.props, this is part of the MSBuild toolchain that .NET Core supports. It works for both F# and C#. And this is where you can define some common properties that are going to get picked up by all of the C# or F# projects that are downstream from this in the solution. So in my folder here in the root directory, I have my solution file, and then I have a source folder, and I have all my C# projects are in here. And I put my Directory.Build.props file inside that source folder as well. So all these properties like my assembly version number, copyright information, and in this case, I've defined some custom variables for being able to specify things like which version of the .NET runtime we use, and also the version numbers for all of our NuGet packages. So Directory.Build.props is where we've kind of done package centralization prior to this feature being introduced. We're going to go ahead and convert the solution to use Directory.Packages.props instead. But these properties still work, and I can actually reference these directly in Directory.Package.props as well. So first thing I think I'm going to do is I'm going to go ahead and create a new file. I'm going to go ahead and save it. Directory.Package.props. And I'm going to copy some of the basic structure here. Let's see if I can get rid of this. Now, the first thing I need in order to make sure that central package management is turned on, if I go back to the documentation from Microsoft, is I need to set this property to true. Manage package versions centrally. This is kind of what enables this feature to work. So I'm going to turn that on here. Okay, so now that'll be true for all all projects in the solution that are further down in the solution directory structure. And then we're going to go ahead and start creating these package version items here. And the way I'm going to go about converting an existing solution to do that is I'm going to open up my project files for both of these. Let me go ahead and grab them. And I'm going to start by grabbing all of the packages that are referenced inside my actual application. So I'm going to copy this, and I'm going to move this over here. And I'm going to paste these in. And I'll go ahead and create, there we go. I'll go ahead and create a little comment using XML syntax. This is at package versions. And we'll do another one for testing later. So Akka.cluster.hosting is a pretty high-level package that brings in a ton of Akka.net dependencies that my solution uses. I don't really need this variable here in Directory.Build.props anymore, so I'm actually going to get rid of it because there's only one package I need to reference that has this version. So I'm going to delete that. We're also going to bump the version to a higher one right now. So delete that. We'll go back to here, and I'll specify 1.02. These three packages, none of them are transitive, so they don't depend on each other. But I want to make sure they're synchronized with each release of Dependabot.command. So I'm going to continue to use this little build variable in Directory.Build.props to help keep them synchronized. So I'm going to continue to do that. I'm also going to delete my... Oh, don't need that anymore. Let's see, Microsoft.extensions versions. This is another variable that's useful to define. So this kind of touches all the different Microsoft.extensions assemblies. So if you have extensions.configuration, .hosting, .logging, whatever, this will go ahead and keep all of them synchronized because these tend to be released every time there's a new update to the .NET SDKs. A new version tends to come out. This will make sure everything gets synced up all at once. So I'm going to continue to use this variable still. But otherwise, yeah, I think that's it for all of our app package versions. Now, one important thing I need to do is that package reference is what we use to reference a package inside a specific C# or F# project. When we want to define what version should all of these projects be referencing, we need to change this from a package reference to a package version element like this. That's the new syntax that this Directory.Packages.props uses to help kind of define what the standard version of this package is that each project in the solution should reference. So now that I've done that, I think everything should look good. Let me go back to my web application, and all we need to do to kind of get this to work with the centralized package management is we just need to delete the version attributes for each of these packages, because that version is now going to be defined inside that central file. So let me go ahead and delete that. Okay, so that should all work. Kind of keeps this looking a lot cleaner than it did before. And the last thing we're going to need to do is we're going to need to also define this for our unit test project. So let me grab this set of dependencies, and I'm going to paste this into my Directory.Packages.props file also. And I'm going to go ahead and grab my comment here, and we're going to say these are my test package versions. So my test SDK version, I'm going to go ahead and get rid of some of my build variables in Directory.Build.props. I don't need to have a variable anymore for the test SDK, so I'll go ahead and just specify that here, and I'll delete that variable afterwards. I don't need that for XUnit either. I'll go ahead and specify 2.42, get rid of that. And then I don't need this variable either for the XUnit runner. So I'll specify this version. Now, all this old private asset stuff, this is kind of used sometimes for build time or debugging dependencies. That doesn't belong in these package version elements. That's all going to be part of the package reference inside our C# or F# projects. We can delete that from here as well. Akka.net. So the only Akka.net package we need to explicitly reference is the test kit. If I had multiple other dependencies that weren't being brought in by Akka.cluster.hosting, let's say I was also referencing things like, I don't know, a specific version of Akka.persistence, or maybe I was referencing some Akka streams adapters, I'd want to go ahead and have separate package versions for each of those as well, or possibly sync them with a variable like this. It's kind of up to you. But in this case, I'm just going to go ahead and replace this variable. And let me delete this one as well, since we don't need it anymore. Fluent assertions. We don't really need a variable for this anymore either. So let me go ahead and replace that. And I can delete this variable. And then we're going to convert all these package versions into package references into package versions as well. So let me go ahead and paste that in all these little areas of the file here. All right, so that should work well. And then I'll go ahead and finish saving my changes, Directory.Build.props. Go ahead and drop back down to one tab. And then let's go and update our test project to make sure it's not specifying explicit versions anymore. You'll get a build warning if you still have your version specified, basically indicating that you're trying to pull in the NuGet package twice. So if you delete the version information from here, everything, that build warning will go away and everything will be kind of locked together as far as the version goes from this Directory.Packages.props. So I'm going to go ahead and compile this real quick and we'll see if everything worked as expected. So my build did actually succeed here, although I did one thing wrong, which is I named this file Directory.Package.props. It has to be Directory.Packages, otherwise this won't work correctly. So I renamed it and reran the build and it all worked fine. However, we did get a compilation warning telling us that whenever you use central package management, we need to use package source mapping in order to make sure this is done securely. So we're going to add that in a moment, but first I wanted to go ahead and show you how the IDE integration works. So we're using Akka.NET's version 1.445 for the test kit, and I think the newest version is 4.9 as of making this video. So if I go to manage NuGet packages right here, and we take a look at the packages that are already installed, I can see on NuGet.org that there is a newer version of this package. So we're using 1.445. The newest version is 1.449. Let's go ahead and upgrade. And we should see that the version that's going to be upgraded is going to be the package version element inside that package, Directory.Packages.props file. And that the actual C# projects that reference this dependency aren't going to be changed. It's only going to be the central, sort of configuration item that's going to be updated anymore. So it looks like writers performed this upgrade. Let's go ahead and take a look at it. And we can see, sure enough, that we're using 1.4.49. Great, so that all works the way we expect. Now, the next thing we need to do is try to address this warning. Basically, when you're using central package management, you want to try to go ahead and either specify either a single NuGet package source, which might be NuGet.org, or if you're supporting multiple different sources, you should really be using package source mapping. This is a software supply chain security feature. Specific scenario it's designed to go ahead and prevent is one where you depend on some public NuGet packages, but you also depend on some private packages that you distribute inside your company. So for instance, you might have some shared middleware that a bunch of your services use. Well, the idea is that we want to make sure that if someone figures out the name and versioning scheme of some of your internal packages, they can't go ahead and publish a package with that name to a source you don't control and have that third-party version of your own dependency get installed instead. So using the package source mapping scheme, we can go ahead and say these packages come from this source, all these other packages come from that one. So we're going to start by creating in the root of our directory. I don't like to put NuGet.config in the source folder for some reason. I always kind of like doing it at the root of the solution. So that's what I'm going to do here. We're going to go ahead and create a new XML file, NuGet.config. And in order to build this, I'm going to go ahead and steal some schema off of the NuGet.org, not NuGet.org, the Microsoft website. I'm going to go ahead and grab this. Now, I think there's one more piece of XML I need in order to actually make this work, which is I think I need a header and a configuration element. Let me go ahead and steal that from one of the other applications I already upgraded earlier today. Let me grab NuGet.config from here. And yes, I need this element at the top. Good old XML. And let me go ahead and close the configuration element. Okay. So when we do clear on this package sources element here, package sources is where we specify all the different places packages can come from. And you can include, authentication details in this file as well. We're going to go ahead and clear any inherited sources. So this means that if I have like 4 sources installed on my machine, which I do, that's why you see this warning show up here. I have 4 sources on here. So I've got NuGet.org, plus I have a local file system package source. Plus, I have a couple of private package sources I connect to for building proprietary software. So what I can do here is say, all right, we're not going to reference any of the inherited sources from the environment or from something like machine.config if you're using .NET Framework. Instead, we're only going to use what's specified in this file. So we're going to reference NuGet.org. I'm going to delete this reference to Contoso since we don't have any. And then we're going to go ahead and specify our package source mapping in the separate element here, where I'm going to specify that by default, all packages come from NuGet.org unless they are one of these packages down here that references our Contoso package source we just deleted. So anything with a pattern of Contoso dot whatever or a package named NuGet.common, that's all going to come from our Contoso source. The other use case for package source mapping can be helpful is if you host versions of packages that aren't available on NuGet but have the same name. Good example, maybe you forked a open source Akka.NET package and you want to make sure you're using your forked version of Akka.NET inside your solution. Package source mapping is a really good way to make sure you're always using your fork of it, not whatever's public on NuGet.org. I'm going to delete that particular element because we don't need it. I'm going to delete this. And I'm going to go ahead and indent everything so it looks all nice and good. All right, so that should all be working. I'm going to go ahead and compile the solution in just a second and make sure that we don't get any build warnings this time. So after adding the NuGet.config file with the package source mapping, you can see here that all of our build warnings went away. So that's all working as expected. And I actually already pushed up this commit as a pull request and merged it into my central repository here, everything all past CI. And Dependabot has already started updating all of these other pull requests that were right here. So I have an example of what one of the older pull requests looked like. So this was targeting our PBM version that was defined in Directory.Build.props. Actually, it's still going to because that variable is still defined here. But if I take a look at, let's say, where we define fluent assertions, for instance, this is now going to be updated inside the Directory.Packages.props. So this dependency is going to basically get updated inside this file, and that'll get propagated to all of the, let's say, test projects in my solution that use fluent assertions. So this is how you can use central package dependency management in NuGet and package source mapping to help build a more kind of robust piece of infrastructure for managing dependencies. The more complicated your solution is, the more this is going to help you. We're going to do another video on sort of what the best practices around dependency management in general are, but I wanted to do a how-to video on these two topics. Since these features are brand new to the tooling ecosystem around .NET, I've not really seen any open source projects using them, and nor have I seen any actual customer solutions that are using them either. So I wanted to introduce them and show you how to set it up inside your own application. I'll go ahead and link to the Microsoft documentation and also our code sample that we used today directly in the show notes. So thank you very much for your time today. We appreciate it. And please leave any questions or comments you might have in the comments. Thank you very much.